In this video we start with exercise number 42. Again, it is a geometric example. We have a tennis court here, and we know that the perimeter, or the distance around the outside of the tennis court, is 228 feet. We also know that a tennis court is a rectangle, so it has the same width and the same length. On the two lengths are the same and the two widths are the same. So if we put a W here, and we know that this is also 2W plus 6. So from this we can make an equation, and I would suggest perimeter. Let's talk about perimeter. One way to look at perimeter is add up all the sides. Another way is to say that the perimeter is equal 2 times the length plus 2 times the width. So in this particular case, we can set up this problem using some distribution. So the length being 2W plus 6. So we have 2 times the quantity 2W plus 6, and then simply 2W for the two widths. From this we know how to solve. And we say that this is a perimeter. It's going to equal distribute. We get 4W plus 12 plus 2W, and we know that the perimeter has to equal 228 feet. So now we have an equation. We can simplify on the right side to get 6W plus 12. On the left side, still 228. Subtracting 12 on both sides leaves us with 216 is equal to 6W. Dividing both sides by 6, we end up with W is equal to 36. Again, that's not the question that's being asked here. The question is, what are the dimensions? So we know what the width is. The width is 36, and the units of measure are feet. For the length, however, we need to multiply to figure out what that is. It's 2 times 36, then plus 6. 2 times 36 is 72, plus 6 gives us 78 feet. So the dimensions are 36 feet by 78 feet. We'll go on to the next problem. All right, in exercise 46, an online ticket agency charges the amount shown for basketball tickets. The total cost for an order is $220.70. How many tickets are purchased? So in this problem, you have to look really carefully when you buy tickets online, because the seller of the tickets is providing you with a convenience. You don't have to go down to the arena or to the stadium to buy the tickets. So it's very convenient for you to use the online system. However, it costs money to build that online system. And so you still have to pay the full ticket price, but you're also going to pay a convenience charge for each ticket that you buy online. And then there's going to be a processing charge. And that processing charge may include the fact that the seller has to go out to the bank to charge your credit card, and then they have to mail the tickets out to you so that you get them. All of that's going to take time for them to program their computers to do that, and it's going to take somebody physically stuffing an envelope with your tickets and putting a stamp on it, bringing it to the post office, etc. So there's a processing charge that is once per order. There's the ticket price, obviously, which would be the ticket price you paid if you went down to the arena or to the stadium to buy the tickets. And then there's a convenience charge per ticket for you being able to purchase the tickets online and saving you the hassle, the time, the expense of getting in your car, driving down to the stadium, and buying the tickets there. So hopefully this is clear. So in this type of problem, we have a per order fee, one time for the whole order, $5.90. Then you have $32.50 for each ticket that you sell. plus you have $3.30 for each ticket that you sell, and in the end we know that the total is $220.70. So this is going to be our basic equation. We see that we can combine like terms. We'll leave the $5. So we can combine like terms on the left side, and we get $5.90, then $32.50, and $3.30 is going to give us $35.80 per ticket, and the total then is still $220.70. So what we're going to do first is take off that one time per order processing charge of $5.90. And when we do that, we're going to be left with $35.80 per ticket, leaving us with $214.80. And that's how much each ticket actually cost. So we're going to divide that, including the convenience charge. $35.80 we're going to divide on both sides and end up with X being the number of tickets, being 6, or 6 tickets were purchased in that particular order. All right? So this is, again, a very important type of problem. We have a one-time charge, and then we have a variable charge, or we have a variable quantity, and we have a constant quantity, and then we have a total. So we add the variable quantity to the constant quantity to give us the total. This is a very consistent type of pattern in many word problems. And I'll scroll up and go on to the next examples. Okay, exercise 49 says an even integer can be represented by the expression 2n, where n is any integer. Find 3 consecutive even integers that have a sum of 54 and explain your reasoning. All right, well, some students are confused because this quantity 2n is given to us, and they're trying to use the 2n to somehow solve this problem, but it doesn't work that way. So what we have here are 3 consecutive even integers. So we do need to define, what does consecutive mean? Consecutive means in a row or one after another. What does even mean? Well, even means that it's divisible by 2, or it has that form 2 times any number. So 2 times an odd number, 2 times 3 is going to give you 6, an even number. 2 times an even number, 2 times 4 gives you 8, also an even number. So an even number is any number that is divisible by 2. Well, so what we're looking for here is 3 consecutive even integers that have a sum. Remember that sum indicates addition. So we're going to have 3 numbers added together, and we know that the sum is going to be 54. So let's talk about how we can arrive at these numbers here, the values to put into those boxes. Now I use rectangles, the same type of box, but it doesn't mean that I have the same value in each one of those boxes, so that should be made clear. So first, we don't know what the first integer is, or the first even integer, so we're simply going to call it n. Now 3 consecutive even integers might be like 8, 10, 12, or 2, 4, 6, or even 22, 24, and 26. So we're going to start with one of them, which we don't know what it is. We're going to call it n. And how do we get from the first consecutive even integer to the second? Well, you can see that we added 2. So the second value will be n plus 2. Then how do we get to the third? You might say we add 2 again, but we're not adding 2 to the first, we're adding 2 to the second. So it would be n plus 2 plus 2, or going from the first to the third would be n plus 4. And so now we can see what our numbers are. The first number that we want is n, the second is n plus 2, and the third is n plus 4. You can't simply write plus 2 in the second box. It's the first number plus 2, or 2 more than the first number, so it's n plus 2. And the third one is 4 more than the first number, so it's n plus 4. Now once you get that, hopefully it's pretty straightforward. We have n plus n plus 2 plus n plus 4, and that equals 54. So we have a multi-step equation. We're going to use combining like terms first. That gives us 3n plus 6 is 54. Subtracting 6 on both sides gives us 3n is equal to 48. Dividing both sides by 3, we're left with n is equal to 16. So, what is that? That's not the final answer. Remember that n is equal to 16, so the three numbers that we're looking for are, or we can say that the three consecutive even integers are 16, 18, and 20, and you should see that if you add those together, you do indeed get 54. So that's how we do these consecutive even integer problems or consecutive odd integer problems. We set them up exactly the same way. The only thing that's going to determine whether it's an even or an odd is what the three total to become. And so that'll do it for this video.